Hello. Hello and welcome in. Hey Max, how are you? And hey, Amiga Build's illegitimate son. You're just stopping in. Excellent. Well, thank you very much. Oh. 1 second, I'm just going to turn down the background music a little bit. Yeah, no, thanks for dropping in. Enjoy your night, and sure, I'm sure I'll see you again soon. Oh, that was loud. Okay, so how are yous? I'm actually think that mic was too loud. Yeah, happy Friday. I know I wasn't that well last week. I'm still not great, but better than I was. So that's good. But oh dear. Yeah, bedtime, you know. Yes, but what I am doing tonight, I'm on the alcohol-free Heineken because I found some outside. Well, I say outside, out in the conservatory, leftover from some session at some point. So I'm gonna have a couple of them probably, and pretend I'm getting drunk. But yes, well, there's a couple of things we're gonna do. First off, we're gonna look at the brand new release of Amiga Blitz 3, and then we are going to look at some copper coding with Amiga Blitz 3, and hopefully it all works because yeah. So what I did earlier was I downloaded the new Amiga Blitz on OS 4, and I literally just started it to make sure it worked, and it did. So with the usual stuff. So now we're gonna try it on the on WinUAE first off. See how we get on under OS 3. Okay. Cheers. Right, so now what I have done is I've downloaded it and I've put it in my shared directory here, which is a Windows drive. Hey, Super Dan, welcome in. I am going to. Oh, where am I? Where did I put it? I'm just about to install 3.11.2, and if I can find it, where's my Amiga Blitz folder? There it is. Amiga Blitz drawer. Amiga Blitz 3.11.2 zip. That's the one. And we're going to put that in work programming. Oh, nope, work programming. That'll do. Welcome in. I'm alcohol free tonight, Super Dan. Unfortunately, I'm still not 100% from earlier. Oh, I don't know why that's happened. Something weird with the unpacker, but zip info.txt. Oh yeah, one of those nights. Not to worry. Okay, so now we should have in our programming folder a new Amiga Blitz folder or directory. Amiga Blitz. I've got too many. Where did it go? Oh, it probably doesn't have an icon. So let's have a look. Yeah, they sometimes go hand in hand. That. Oh, there we are. Amiga Blitz 3.11.2. So let's give that an icon. So there we go. And there we have it. 3.11.2. So what I'm going to do is I'm going to leave out this folder. Icon leave out. And that'll put it on the workbench. And so it'll be there somewhere. 3.11.2. Yeah, actually, you know what? Let's give it a Blitzy icon. There we go. So we know what we're dealing with. Okay, let's see if it works. Oh yeah, that's fine. It does. It sets that up from the first run. I meant to read the. Oh, that's the main README. Where's the changelog? Let's. Oh, it's working. It's doing things. Oh, it's opened a much larger screen mode than it should have. I presume that's... Oh, it's opened... it's Honeyto's screen mode. Okay, ID preferences. Environment. Yeah, I presume he's using a 1600 by 900 window. So let's go with that. And that looks horrible. So let's redo this. Sorry for the... Oh, come on. It sort of... when you resize the window, it will sometimes... There we go. It'll snap to the right size, but it's a bit clunky. Oh. It still thinks it's resizing. Yeah, the resize code is a bit shit. Oh, where's it gone? Come on, don't make me go into the window and type in the numbers. There we go. So now that should be visible for you. Yes, there we go. That's how it should look. Okay, so here's our setup. The windows are a bit all over the place, so we're going to rearrange them in a little while. We're also in a dark color scheme. So I know dark modes are all the rage, but I'm old school, so I might change that. But it started. We've got ourselves a nice fresh environment. Okay, so there's a couple of things I want to fix. First off, ID preferences, we already saved that, so now it should be the right size for Workbench. Yeah, we're going to get rid of this log for a start, so let's quit that. The log, oh, I can't remember. Dun, 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 dun. Dun, 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 dun. Log level, log mode. I can't remember the things, so I'm just going to switch them off. Log mode, console. No, that didn't work. Log level. Oh, sorry, I thought I clicked that one. It was that one I didn't want to click. There we go. There we go. Now, next we need to arrange our windows. So let's. Oh, I can't. On OS 4, you can maximize a window by holding down Shift and clicking the zoom button. Cannot do that in OS 3. I could probably import the settings from an earlier version of AmiBlitz, but let's not do that. Something like that. I'm gonna line it up pixel perfect because it'll annoy me otherwise. Okay. Now, and ID preferences and the editor. That one says store layout. Save. So that's our F4 layout. Cool. Okay. The obligatory hello world and file and run. It worked. Oh, we've got different colors for the console. It was blue and now it's white. This program terminated. Hello world, it works. Excellent. We're working. We're running. Oh. These are the shortcuts from someone else. What's new? Change log. This is the old changelog. This isn't the changelog of... Yeah, this is a changelog when I went to AmiBlitz 3. So, okay, right. Let's see if where's the... You can't see it here, but basically changelog is this is the Of Mice and Men release. So this latest release, you've got some compiler fixes, some IDE fixes, memory hits, and last window dimensions of console window and log window will be stored too when saving the window layout of the IDE. Cool. Blitzlibs added support for identified.library. Okay, identified.library is quite cool. Identified.library, it looks up all the autoconfig hardware, like all the ID codes and stuff like that, and gives you kind of actual like human readable names for them. It's cool. Fix some other bugs. Logging include. Added examples for using identified.library. Oh, and autodoc. Minor improvements to the help viewer. Okay. Excuse me. Let's have a look at some of these examples. What's this? Oh, these. So the library structure has changed a bit since last I looked. Docs. Miscellaneous. Blitzlibs examples. Okay, we've got some stuff in here. Where is identify.doc? Okay, so this is just the actual text of it. So yeah, these are just the the functions needed. Like that's the autodoc for the library. But where are the actual examples? Source codes. Ah, okay. This is different. So okay, Blitzlib examples. They're kind of. So they're a bit all over the place, I think. So some of the examples are in with the documentation in here. Lots of them are there. Are they? Yeah, sorry, they're the examples there. So there's some there, and they're the ones that are supposed to be loadable from the guide, and there are some in source codes. Blitzlib examples. Oh, PT player example. Excellent. That's good. What was I looking for? The identify library. Oh, loads of GAD tools examples. That's cool. Nice. But what we'll do is, yeah, that's cool. Triton Tool Manager. Javier, welcome in. Hey, happy Friday. Happy Friday. I'm on the alcohol-free beer. So I'm still not well. But we're looking at the new AmiBlitz 3.11.2. And yeah, we're just looking at some. He's got some cool example code. Now this is probably a old example code that I just haven't looked at before, but because I haven't spent that long looking at them. But OS library examples identify. This is what we're looking. Oh, BSD socket library. Oh, nice. It's definitely not a day for drinking beer outside here. It wasn't freezing, but you know when it's cold enough that the rain starts to sting you. Your ears start to sting. It's one of those kind of days. So ah, yes. Okay, so let's run this example here. So this is the expansion library is for identifying the different hardware. Hey George, welcome in. Welcome in. I am giving this stretching the legs of the new version of AmiBlitz, and one of the things it adds is support for identify library. So I'm just gonna run this and see what happens. Oh no. Straight away, what's going on here? What's going on there? Dim tags.tag item. Here it rains for yes. What's going on here? Oh, tags is a keyword, isn't it? Dim tags. So we're going to have to change that to, so that's odd straight out of the box because that clashes with a keyword. Well, it worked fine because, you know, we all knew the pitfalls and knew how to avoid them. But, you know, things like, you know, adding new features is a good thing as well. And there are quite a few issues that have been fixed, I believe. Tag item. Tag item is definitely a struct type, isn't it? I can't even check. Tag item. Yeah, it's like an compiler settings. Oh, what's going on here? Something's not right. Surely it's not. Oh, there's a thing. See that? So it looks like if there's a quick pop-up text going to appear, that the menu won't trigger. So if I look, if there's one below where the menu is, it pops up that instead. Okay, now I don't know if that is a magic menus thing. It is a magic menu thing. So it's non-blocking magic menu. Oh, that'll be awkward to work out. But all that res is there. Why is that not working? Constant not found. Sorry, I didn't. Constant not found. ID tag config dev. Is there a new? Oh dear. Well, what we'll do is let's open the help page for expansion library. Get to me. No, it doesn't tell us anything about the library. So I'm gonna have to look more into this because these are the constants that belong to that library. So it's possible that they haven't been added to all.res. So I'm going to make a note of these issues and then we can maybe report them afterwards. So, what was the first one? When magic menu. And then we had, what's that? What was, yes, a constants for. I'll report this afterwards and see. Maybe actually Honeytos might be along, and we'll have a look. But anyway, okay, so right, that example isn't going to work without serious stuff. So I'd imagine it's the same. Oh, is that the one I was looking at? Function. This will be the same, no doubt. Tags. So yeah, tags. Oh, that's a weird one because out of the box it should work. So I don't know if there's some difference in the libraries that Honeyto's running. Okay, right. So let's have a look at the other examples anyway, because that one's a bust. Apparently there were new MUI examples. These look like the standard MUI examples. Let's have a look. Yeah, that's the standard. Standard. The class is rouge. Ooh, the debugger looks different. Debugger. No, nice, nice. Okay. Anyway, that's an already existing MUI. Oopsie. Ooh. Oh, this is interesting because Boopsy is the standard, like sort of the OS system for adding, for controlling gadgets and adding gadgets. It's the object-oriented GUI engine, really. So interesting that there's an example. Oh. Now it's time to try out the new debugger. Oh, I think I know what it is. It's just the debugger is font sensitive now. So, yeah, that's why it looks different. Text field, gadget, new objects, lib. That's got a value, so that it did find it, and so that's 0. Oh, that's a null. So text F array. Then text F to tag item. That shouldn't return a 0. That's really weird. Really weird. Okay, we're not doing that well now with the example code, the new examples. Let's try something simpler. Why is that not tokenized? Because in text mode, that's weird. Weirdness. Array not yet dimmed. Open library. That's a standard system call, isn't it? Yeah. So why is it not? Why is that saying? Oh, it's the bracket missing off the end. Oh, so yeah, yeah, there's badness happening there. Okay, we're not going to look at that either. Let's go back out of here. OS library examples. Okay, recording sound. That's cool. Let's classic examples. Oopsie demo. Classic examples. Has that worked? Oh, it has worked. Hello. A text object is clearly the wrong size. Cool. Okay, that's Boopsy. Working. Gadget list. Okay, cool. So that's good. You can basically that's it, creating the gadgets in the same way you would in C. So let's look at what we're doing. Brex is sort of it's a built-in Blitz macro recorder, which is quite cool. Stencil. Ooh. Well, that's on an OS friendly screen. Oh, that's cool. So it's still using the blitter directly, but using stencil blitz. to do some overlapping stuff in an OS friendly way. That's quite cool. Let's run that again, have a look. Nicely done. Blitz font. Which font? Oh, this is using font without loading the font, isn't that right? Ooh. Okay, right, I don't know that. I'm not going to spend time faffing with the things. Missing files and stuff. Event here. Event here. Oh, look at that. Clever. Clever. Cool. Excellent. How do I quit? Quit! Is there a hidden window? Oh no, it didn't trigger the debugger, so I can't. Surely. Oh, there we go. Escape. I could have read that. Doesn't that transparency in the menu? This transparency? Yes, but that's not the point. The point is it looks cool. It's normally a lot better on a light colored screen. It's much better, much easier to read. It's just because that's on a dark mode kind of screen. That black text in the menu isn't very easy to read. So I wouldn't normally have. I'm not a huge fan of dark mode, to be honest, because I'm old school. Oh, Super Dan, if you're still there. I'm wearing my Norway t-shirt for you. Yes, exactly. It is so I remember when Magic Menu came out first and I had a graphics card, or or maybe it was already out, but I had a graphics card and I got a graphics card, and one of the first things I did was switch on the transparency and run it with a 24-bit background and transparency in the menus. I was like, this actually looks really cool. It was so good. But yes, exactly. It's something. It's a badge of honor. But I would use Magic Menu anyway because I like the menus to be more accessible like that. But the transparency and the blurring is just kind of a nice thing. And sure, isn't that all the rage these days? Isn't both Windows and Apple now doing blurring and transparency in their menus? There you go. We had it 25 years ago. Putting the Voodoo 3 to use. You remember those patches of patterns on what? Oh, yes. Yeah. Oh, what was the name of it? Because what was the name of it? Yeah, it was one of those patches that worked really well 99% of the time, but as soon as it put a foot wrong, it took the entire system down with it. But it was if you did it well, it looked really, really good, and it looked, especially on a graphics card, because all that extra blitting was kind of for free. Well, yeah, but that one in particular, because literally drawing a window would trigger the patched routines. So if anything went wrong, literally just like moving a window can destroy your system. It wasn't. There was a specific one for the patterns. Birdie. There we go. Birdie. So the visual prefs, which I still like and I still use, that gives you the styling of the gadgets. And Birdie was the one that would let you patch the drawing routine. So instead of a block fill in the window title and in the borders, you could put a bitmap, and it was quite cool. But yeah, OS4 gives you that as an actual feature. But it was one of those kind of, this is cool until it shits itself. Alexandra, yes, welcome in, by the way. Yeah, I had the Voodoo 3 in my one as a PCI Voodoo 3, and it was a great card, and I still have it, still works. And I eventually disabled Birdie after I got fed up with it, just having problems. But yeah, it was great. It looked really good. But you reckon I've got too much transparency here as it is? So we have the icon library. So icons without an icon file are transparent, and I've got my transparent menus. I like my transparency. What can I say? Okay, so that example's fine. I have to look at this AGA voxel space Comanche. Come on. What does this do? Ooh. Is this responding to my? Oh, yeah. I'm moving. I'm turning. How do I go forwards? WAST. Yeah, W. Oh. Frames 1 per second, 2 per second. Oh. Yeah, visual prefs is good. I like visual prefs. Oh, keyboard is stuck. Now, was that running? Let's turn off the debugger and see how that runs. Oh, look at that. That's cool. Okay, yeah, enough of that. Oh, that's system friendly, I presume, because it's been. Actually, I don't know. No, maybe it's not. But that's cool. Yeah, no, it's display bitmap. So, pixels moving at 2 frames a second. Yes. Other examples. What was in here? Escape sequences. Yeah. GL. Is this OpenGL? Oh, to run this demo, you need to storm these AGL libraries, which I don't have. So yeah, but let's not, because it could be bad news. That's interesting. Simple 3D tutorial. Ooh. Ooh. Needs a bit of double buffering, but that's impressive. Right. Next game's going to be 3D. What do you reckon, Super Dan? 3D and system friendly. Oh no, that's a 3D object. Not what I wanted. What's this one? Ooh. New. They're all the same, are they? Yeah, that would. Let's not worry about that. Okay, now I'm afraid to try my old code just in case it doesn't work in the new version of Blitz. Excuse me, but we should check. Classic example, Blitz mode examples. Let's see if there's anything fancy in here. Star scroller. Pretty cool. I think some of these were already there. Yeah, I think some of these are already from. They were included with the original Blitz. Like some demo effects. I think this one has. Yeah. Wait for it. Look at that. That's quite cool. Yeah. Yes, just real-time render the blocks instead. This is quite a cool little demo effect. I remember this. I remember thinking, "Oh wow, that's amazing!" And then I saw how it works, and I was like, "Oh, okay, it's not. It's a nice effect." But it's very clever. Very clever. It's quite cool. Dual playfield. Darts polygon. Oh, this is kind of cool. More 3D-ness. Okay. Oh, oops. Initialize bitmap. Okay, so there's a lot of assembly in that. Triplanes. What's that about? Whoa. That's cool. That's quite cool. Look at that, and it's faded at the top and the bottom and everything. That's trippy. That's very cool. Ooh, that's not what I want to do. That's cool. Okay. Oh, mouse of 2. Oh. This is dual mouse support was added. Is it? Yeah, yeah. So this is in I don't know how to emulate a second mouse. Let me see what I can do. While I'm going into the game ports, I have to go in here. So port 2 is HID compliant mouse. Yeah, so they're both connected to the same mouse. But yeah, look, this lets me run 2 mice at the same time. How cool is that? For 2-player games. And one is accelerated and the other's not, by the looks of it. See? Oh, that's interesting, because one was a Windows mouse, one was HID compliant mouse. And they run at different speeds. That's cool. That's cool though. Being able to use 2 mice on original hardware, like Lemmings and Settlers. Yeah, I think I need to change my color scheme. Definitely. Lines with copper split. Oh. Let's see what's going on with custom copper. Okay, this is just literally inserting the raw commands in. Well, let's see what it does, because I don't know this. But this is using old school, because this is... Oh, that's another nice effect. What do you reckon? Should we come up with a Blitz Basic demo? Have that as the selling point. You're never going to beat anything that's like hand-tailored assembly, but to have a demo at revision that was written in Basic would be awesome. Out of alcohol-free beer already. Okay, let's do a playfield. See what this is. Standard. Yeah, these are the old demos. So classic Blitz mode, Blitz lib examples. If one would host a Blitz Basic demo jam. Yeah, that's true. Yeah, you get to a certain point and then yeah. Chunky. What's this about? Oh, chunky bitmaps. Oh. Was that because the debugger's there? That was weird because it let me recompile it again. Don't know how stable this is going to be now for the next while. Okay, so anyways, that's cool. Evening John, how are you? Welcome in. I've started off just by looking at the new Ami Blitz version that's been released and going through some of the demos that come with it. Some of them are old demos from back when Blitz Basic was on floppy disk. Back in those days. So we've been looking through, but there's some cool stuff like dual mouse support. It's the first time that Blitz has had that natively. So in the past, what you had to do was read the mouse manually basically write your own mouse reading code. But now Blitz supports 2 mice, so that is interesting because I actually have things in mind that I could use that for. Yeah, absolutely. Yeah, so I was just having a look at a few of the demo things that are in here. Mildred 2D Pixel Explosion. So Mildred is a graphics library, one of the third-party graphics libraries that Blitz came with. Ooh, that's quite cool. Yeah. So the Mildred library is a chunky. It's a chunky graphics library which lets you use kind of chunky graphics, and then we'll do chunky to planar conversion. So it's a nice effect, isn't it? But there've been a lot of these demos that are kind of like, oh, these are all cool demo effects. Yeah, but Mildred is quite a comprehensive library. It's very cool. I could be wrong, but I think the game Foundation is written in using Mildred. Let's see, like explosion. Yeah, yes, absolutely. As like the old Windows screensaver. Database Blitz book. What's this? Let's have a look. Oh, address book database. Yeah, cool. Fine, I'm not gonna go through that. But I'm nervous. What I want to do was I wrote code when during the week that uses a different because I was struggling to get the copper effect that I wanted in my my SkyBlocks game. So I wrote some test code for one of the other copper libraries, and it actually works really, really well. So let's bite the bullet and give that a go. Copper test. So so what this is doing, well, let's run it and see if it works actually. Oh, okay, so it's almost working. We've got a little glitchy line down there at the bottom, but we can fix that in a minute. But basically, there we go. We've got a gradient that we're scrolling up and down. And I was very, very happy to get that working. So because I could not get that to work by working with the standard Blitz copper library. And it just turns out I was trying to make it do things that it was not supposed to do. But that works lovely. What a weird tune. That's awful. Let's go do something. There we go. So yeah, it's that copper effect would be cool in your game. Yeah, well, that was the idea, was to scroll the sky in the background, you know, at half speed, so you get like a sort of a slight parallax effect. So that's what I'm going to do. So now what I'm going to try and do is I'm going to try and port this effect into my game. But first off, what I want to do is I want to fix the glitch, but I'm going to go through the code, especially because there was a special request from Zuperdan to actually go through the code here. So what I'm going to do is going to explain it and at the same time fix that little glitch at the bottom, which is just it's just a DMA thing, because the I'm trying to move the mouse pointer, and of course there's no mouse pointer. The bottom, that box, the white box on the screen, that's the full limit of the bitmap. So there shouldn't be any graphics data below that, and it's just I've just miscalculated somewhere. And it didn't show up for me before, possibly because it changes every time you run the emulation, you know, because that's just whatever happens, whatever bits happen to be set in memory. But what I'm going to do first is I'm going to go get another drink. So talk amongst yourselves. I'll be back in a second. And the background mod too, you can add it and rise pitch on higher levels. Well, that's the thing. Raising the pitch of a mod, I think, is just too complicated. Not worth the effort, basically. So I'm just going to use the same little short sample and change the pitch of that. So it sounds good. It's just a shame it's alcohol free. But hey, you know. Great. Okay, so that works. Let's see what the glitch is about. So like I said, I think that's just because that's just because of it. The DMA is still running too low. So basically this is called the ORI copper list. Hold on a second, something is... Oh yeah, that'll do. Sorry, I changed the windows in the background and there's things going on. I'm like, oh god, distracting. So if you look, let's have a look at the help files anyway then. And so the Blitz libs. Oh, this has been rearranged as well in this version of Ami Blitz. So normally you have the core libs and the def libs, and the core libs are the central, the core Blitz Basic libraries, and they're the commands that are the like your blitting commands, your very standard commands that are in even the smallest version of Blitz Basic. When you boot it from a floppy disk, they're the commands that are available. The def libs, or the third-party libs, are all contributions by different people. Some of them working for ACID, some of them working for Red When Excited, as you can see there. And so what happened was it was sorted into the core libs and basically the extended libs, but they were still part of the standard Blitz Basic distribution, so everyone should have had those commands. Now over the years they were updated and there were, you know, changed and additions and fixes made. I'm Immortal, welcome in, happy Friday. I'm having an alcohol free beer, sadly, because I'm still feeling a bit rubbish from last week. You know, I was dying. A couple of days during the week, couldn't get out of bed. I was getting out at 2 o'clock or something. But anyways, the docs have been rearranged a little bit. So the base libs, yeah, so they're just a very, very standard, like the very standard commands. Yeah, all that stuff. All the stuff that's in the Blitz Basic manual. Cool. Well, glad to have you here. Utilib. So these are these are the third-party libs, but I don't see the so these are like, you know, these add a lot of extra commands, and these aren't in the manual for the standard Blitz Basic manual. So these are, but there's some missing. So let's see. Yeah, so now we've got chipset related, so the graphics and sound related, and these are broken links, JPEG library information. Okay, so these are OS libraries. So this is what we're looking for: chipset libs and ORI copper lib. That's what we're looking for. So this was a third-party contribution. So these commands were added by someone else, but they are part of Blitz Basic since, well, you know, the version that I got, 2.1, they were included with that. So they're a little bit lower. I'm not sure if these things work. I don't think so. But basically, I took one of the examples from this library and used it as a basis for my thing here. So this is just because you're just in here, Andrew. This is my test program for how to mess with the copper. So I can scroll it up and down. And that's the plan. or that was it. That's what I was planning to do in the back of my little game, and now this lets me do that. So if we look at this though, this this library, it has lower level things, so it should work on ECS, yeah, or OCS. Like this is that was some nice moving copyright. Thanks, James. You're fitting right in. See, we'll make an Amiga of you yet. Nice Metallica mod, is it? I'm not sure I recognize it, but well spotted. So what's happening is, for anyone who doesn't know, right, the copper is a little it's a portion of the Agnes chip. It's Unforgiven. And that's it. Anyway, so the copper is a little part of the Agnes chip, and the job of the copper is to no, you're sure you're an old hand at this. So basically, what part of what made the Amiga so special at the time was that it had all these custom chips that could do loads of extra work while the CPU was busy doing other things. So you could have a computer that was just a CPU, and the CPU would have to draw the screen. The CPU would have to, calculate all the positions of things and draw the objects and redraw them and move them. And then you had the Amiga, where you had Blitter and Copper and Paula to do all those things for you. And that meant that you got what it was able to punch way above its weight. And that for that very reason, because what you can do is you can tell the CPU can tell the Blitter, draw all these shapes over here, and then the CPU can go and calculate enemy moves or do some other work in parallel, and that's it. Well, the Copper draws the screen basically. It decides what pixels go out when and where, and it's a very sort of low level thing, but it is basically the idea is that it's a very simple CPU by itself, a simple processor, and it only has 3 instructions, and they are move, wait, and skip. But the entire thing is synchronized to the display, which means that you can get. So what it would do is its official job was wait until the monitor beam, if you look at my hands way above there, wait until the monitor beam is right at the start, then switch it on, and switch it on white, and then when it goes down along, and switch it off again. And that's kind of what the Copper would do. So it would also do it at the side, so switch off here and switch back on here and go across, and switch off, switch back on here, go across. So it was that was the instructions. That was called Copper list, that the Copper would use to build up the display. And of course, people very quickly learned you could modify that, and you could get it to do other things, because it wasn't just able to write to the specific parts of the computer that dealt with controlling the graphics output. It could write to any parts of the chipset, and people are like, "Oh, so what we're saying here is we can change the colors on the fly." So that screen that my software is running is only using one color. Oh, sorry, it's using 4 colors. You've got the background, you've got black, you've got white, and then as a color that isn't even used. So it's 3 colors, and the background color is black. But what I'm doing is I'm telling the Copper that after 16 lines we're going to change the color to this. After another 16 lines we change the color to this, and so on and so forth all the way down. And that's what it's doing. So we're just adding in these extra little instructions to this little processor and saying, hey, go and do this, go do this. So that's it. So what we do is we have the wait command that says wait for line 20, let's say, and then put this value into this register, and then wait for another 20 lines, this value into this register, wait another 20 lines, this value into this register, and that's what it does. So what you see there is a pure black background, and you know, so as far as the CPU is concerned, that's black screen. But the copper is doing this completely for free, with no CPU intervention, basically. So when now the CPU is moving the cop list, it is telling the copper to do it at different points each time now. But that's all the CPU is doing. It's not drawing any lines. It's not filling in any boxes of color. So it's a clever little trick, and so many Amiga games were known for being colorful and having these kind of bright rainbow backgrounds, and text would have like different colors in different parts of the screen and stuff like that. And that's all with the copper. So yes, that noise, Super Dan, and it's a good question, because normally what would happen is, well, exactly, yeah, it's extra colors for free. But it could do other things as well, like you could reset the sprite hardware. So, you know, if the Amiga has 8 hardware sprite channels. So what you could do is you have 8, you know, hardware sprites, and they could all move and interact with each other and stuff like that. But if you had a section of the screen where they weren't overlapping, for example, player 1 and player 2, you could use the copper to reset the sprite hardware and have another 8. And you could do it again and again. So as long as they didn't have to overlap, the copper could reset the sprite hardware as many times as you wanted. And you know, the being able to drag a screen down on the native screen modes, again, that's the copper. So what happens is on an Amiga, well, see, this is set up for a graphics card screen, but on an Amiga you can I'll show you now. When you're on a native screen mode, this is 806. I'm just going to look a bit clunky now, but let's put it in PAL high-res list. Oh, blitter objects as well, yeah. Oh yeah, no, it's probably not going to play ball. Oh, let's see. Oh. It's not really going to work, is it? No, it's not, because we've got a lock on the screen. But basically, if you have what do I have that'll open a native screen mode? Personal Paint Skipper. No. Maybe. Image format. Let's open. Yeah, no, it's not going to. We're back. I'll pray. All right, cool. Enjoy, Andrew. Good night. Thanks for dropping in. So basically, anyway, you can't do it on the graphics card because the graphics card doesn't have a copper. So you have to fake it. But so on the native Amiga screen mode, you can grab the top of the screen and pull it down and see the screen behind it, and all you have, it could be a different resolution, different color depth, and everything. Whoops! And all that's happening there is at a certain position down the screen, which is wherever you've dragged it to, the copper resets all this display hardware and says, right, you've got a new display now, different resolution, different colors, whatever, and for the rest of the screen, that's what you have. So it's really a very clever system. But anyway, so that's what the copper is doing. So my copper effect there is basically just yeah, it is kind of, it's one of those specific Amiga things. But yeah, blitter objects. Blitter is the other thing that can do, and that can move chunks of graphics around on the in the what's called the chip memory, in the video memory. It can just move chunks around, again, without the CPU being involved. So, you know, drawing big things can be and drawing moving objects is you can do that. Basically, all the CPU has to say is take this chunk of graphics and put it on the bitmap here, and then take it and put it there, and take it and put it there. So the CPU is given very minimal commands, and then the blitter is doing all the heavy lifting. And it means the CPU can go and do other stuff, like doing collision detection or AI, you know, pathfinding, or you know, anything like that. So yeah, that's it. That's what made the Amiga hardware so cool. But that screen pulling down is fantastic, and they brought it back in OS 4 because every screen is basically a surface. So you know, because it's on a modern graphics card, so it's a modern compositing engine. So it's the same as Windows and everything. Like every window and every screen is just basically a polygon, and so you can drag it, and means you can even drag it to the side, which is something you couldn't do before. Well, exactly, yeah. So the Atari ST had a faster 68000. So there were occasionally games, usually 3D games, where it might have had a slight edge, but every advantage was lost when you did anything with the custom chips. And the big example that I can think of is what's it called, Pac-Mania. And if you compare the Amiga version of Pac-Mania to the ST version, it's like night and day. That's mainly because of the blitter, but also it also uses the hardware scrolling and the sprites, the hardware sprites, and the ST had none of that. So I know there's an updated version now for the STE which does have a blitter, but this is 30 years later. But yeah, anyways, right. So there's our copper moving. Dan, this ORI library allows you to do multiplexed sprites. It does not. This is the cops and robbers. Oh, I see what you did there. Way. But look at that for a beautiful, clean, scrolling copper bars. I was actually really proud of that when I got it to work. But this ORI library doesn't actually. It's lower level than allowing you to multiplex the sprites. So it definitely does look better, doesn't it? Looks nice and smooth, and no glitches apart from the glitch that Super Dan pointed at the bottom, and I'll talk about that in a minute. So yeah, so resetting the sprites, what you need to do is you need to write certain values to the sprite control registers, you see, and that resets them. So you turn off, I think you turn off DMA, you reset certain things, and you turn on the DMA again, and you can get the copper to do that at a certain Y point. But the original Blitz library for controlling the copper will do that for you just fine. So it's called custom sprites, I think. There's a command, and it just uses custom sprites, and you tell it what Y position to do it, and it does it. So this library is a lower level library, and it lets you put in the actual commands. So instead of saying reset the sprites at like Y 128, you have to say put this value in the DMA control slot to disable DMA, then reset these values for the new pointers, and then put the DMA values back in, or whatever the sequence is. You have to do that. Yeah, initial Amiga games didn't use much of it because there's that, and there's the whole right, we've got a game now, we want to release it on 3 different platforms, and let's do the lowest common denominator and fuck it, get it out the door, get the money coming in. Yeah. There's an awful lot of that kind of crack. So it's only when kind of the ST was, I suppose, in decline, or in certain things like the Pac-Mania example, where they did actually pay attention to the hardware, that it came out really, really well. But yeah, the Pac-Mania is a fantastic conversion of the arcade game. It's well worth a go, because it's full. It uses greater than the size of the screen because of how the Amiga hardware works. Because remember what I was saying earlier, that the copper decides where to switch on and off the beam going across. Well, you can just like leave it on and like read a bit more memory, and that's called the overscan area, and so you can make the screen wider, and that's what it does. It's yeah, that's it. Now so yeah, you can also reset the sprite. You can multiplex the sprites across the way as well, but that's not something I have successfully done. That's a lot more complicated, and it requires a lot more precision timing. Yeah, I've done that and got loads of glitches and all sorts of shit happening. So it can be done. There are lots of games that do it, and they sometimes do it for making a kind of a repeating background pattern. So use the same sprite or the same 2 sprites, like sprite 1 2 1 2 1 2 1 2 1 2, all, and fill up the screen. And it's a nice way of gaining an extra sort of layer. But yeah, doing that is a lot more elaborate and complex. So there is only so much the copper can do as well. So every time the copper does something, that takes the copper time, and you've only got so many slots. So I think one copper instruction is like 4 pixels. Well, there's that as well, yes, because the copper, if you're telling the copper to access these different registers and stuff, then, you know, you're actually using the custom chip bus for the copper to do that. So you're reducing the amount of time that the CPU has access to the chips. So there's a balancing thing there as well. So when I say like this effect that I have here is for free, it's not for free. It's very, very cheap though. It's a hell of a lot faster than drawing all those lines with the CPU or even the blitter. But it does mean that the copper needs to write 4 registers every line, or every 16 lines or so. Oh, turbo outrun. Uh-huh. A few weeks ago, yeah, that would definitely explain things, wouldn't it? Anyways, right. Wine on a can. Yeah, no, I'm still feeling a little bit rubbish. So this is some alcohol-free beer that I found out in the conservatory where it's nice and cold. But you never know. I might, when I finish this, I might go and find a real drink. We'll see what I have. I do have a booze shelf. We'll see. Anyways, so now what Zuperdan asked about, and I hope people appreciate that my copper gradient is copper colored. Can I change the copper color? Yes, you absolutely can. I'm going to answer your previous question first, Zuperdan. That glitchy stuff at the bottom, that glitchy stuff at the bottom, basically what happens is normally the copper will switch on the bitplane access at the very top of the screen, so you start getting your bitmap, and then when it gets to the last line, when it finishes drawing the last line, it switches it off again. Now, because I've been fucking with the copper, it doesn't switch it off anymore, and I got an extra few lines underneath, so even though the screen ends at that white line, it's still fetching information for another couple of lines, and that is just random stuff that's in chip RAM. So it's probably different every time, and it's not doing any harm as such, but it's not pretty. So I'm going to fix that, and then we're going to change the copper color to the white. Let's do that. Let's experiment. Oh yeah, I wanted to show you that the commands in the library. Where is it gone? So we've got copper command. So problem you had your game on the right side of the game. Exactly, yes. So I'm sure that was what Nivri was saying, was the copper weights were in the wrong place, or too early or something like that. But I don't have access to it because that was too high level. So I like this without, because I don't have to handcraft the copper list, but at the same time I'm controlling the bits I want to control, and I think that's a nice kind of compromise and doing it in a basic way. Okay, so these are the 3 commands we have. We've got copper skip, copper end, and copper move. So, oh sorry, copper weight. Sorry, copper weight and copper move. That's a pretty cool story to tell, though. So this isn't the same thing as the infamous outrun. Sorry, I see. So copper weight basically just puts the copper to sleep until it reaches a particular X and Y coordinate. So it is kind of, if you do it manually, it is slightly finer grained, but yeah, you can see there's multiples of 4 pixels. So that's basically your copper resolution. So you pick X and Y values of the screen, and that's it. Copper move is, if you're familiar with assembly, move is the usual command for moving an information. Hashtag lamer. I'm very comfortable at my old age. Very, very comfortable on my basic. So copper move, you can see there register and value. So register is just the chipset address of the where you want to put the thing, and value is what you want to put in there, and it's as simple as that. So what you would normally do is you would do a copper wait until where you want that, until a position on the screen where you want to change something, and then you do copper move to change it, and that's it. And if the position is already passed when it gets to the copper wait in the list, then it'll skip straight to the next command. And copper skip just skips the next command. Allows you to insert wait instructions, copper list, horizontal and vertical positions. That's the wrong text. That's just a copy and paste of the copper wait. But the copper skip, basically, when the XY condition is satisfied, it skips the next step, and that's it, as far as I know. I haven't really used it, but yeah, basically that's it. So the copper list is then just a matter of adding up all the steps that you want in the right order, and so waiting, doing something, waiting, doing something, and that's it. So there are a couple of extra commands in the library that are for setting things up, like copper reset, copper, yeah, there's a few other things in there. So we started out, we're creating our display as we would normal. We're creating, what I've done is I've made up some colors and stored them in here. There are coppers, our copper colors. Excuse me. We've got 15 of them, and our offset, that's the kind of, like, at the start of the Amiga display hardware is kind of up above the screen, like I was saying earlier about the overscan. So typically a standard PAL display starts at 44 pixels down, so that's what we use as the offset. So we start off the screen there, and it's 320 by 256, and we draw a little box on that, and then we go to create copper. But we're just creating the display as standard, and then all we're doing is we're counting up, we're creating a new copper list every frame, and the new copper list is just basically the same as the old copper list but moved down one. And so that basically what we're doing is we're overwriting the commands that are already in the copper list, and that resolves the issue earlier that I had with the old Blitz library way of doing it, which was that the existing commands were left in place, and I was inserting more copper change commands, and it just got messy and horrible, and it wasn't the right way to do it. So we're creating a copper. So copper reset, basically what that command does is this copper library has a kind of an internal copper pointer, so that sets us back to the start of our list of commands. Not the copper itself, not the copper list itself, but it's the start of the commands that we can influence, or that we want to influence. So we're back to the start at 44. Offset. Sorry, we start at 44, but we're changing that. And Y is our distance down the screen relative to the start of this for this particular copper list. So what we're doing is, we'll ignore this for a while. I've got some comments in, but we're just saying RG and B are variables holding the color, and we're going through a loop of the colors. So what we do is we wait for position Y. Don't mind that. Oh, our tokens are gone. Let's redraw that. Okay. Why are we doing this? Oh, we are. Sorry. Yeah. Sorry. This is. 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 we're making sure that we're not down too far on the screen, because if we're down too far on the screen, we're going to be changing the copper. And what happens is you reach a certain point and it wraps around into the next part of the screen because you've gone on too long, and the screen has started again and the copper's still going, wait, you've got these lines to do. So you end up with color at the top. So I found that to be about 50 pixels past the end of the screen. So we're not changing once our copper reaches, once any of our bars reach 50 pixels on, we don't do it. So what we're doing is we're waiting for the Y position we want, and then we're setting register 180 to the colors, red, green and blue, and that's all. It's very simple. So it's basically it's a 16-bit. The color registers for ECS and OCS are 16 bits, and it's just 4 bits red, 4 bits green, 4 bits blue, with blue being the least significant bits. So that's all we're doing there, is we're combining the red, green and blue bits together to make a 12-bit number, and we're putting that in 180. Now, the 180 is the local chipset address. So all the chipset addresses start with DFF. Doubt myself now. So yeah, so if you're to access this register with the CPU, it's DFF 180, and that's the full address. But the chipset is only able to register within a certain space, and they all so you can drop the DFF off it altogether. And so all the registers are within a certain distance, and so you only need the 3 digits. And so that's the local address that you use. So the copper can access 180, which is the background color register, and it stores the new thing in there, but it only does that after it's waited for Y position of the offset. And then we add 16 onto that, and that's it. We go around the loop again, and every 16 we do the next set of colors. If you want to do it in AGA, you can, of course. Now the AGA registers are different, because for backwards compatibility, what they did with AGA was they still kept the ECS registers. So there are 32 12-bit ECS registers, whereas there are 256 24-bit registers for AGA. So what they did was you have to write the AGA values in 2 parts. Yes. And what I like is you can do it. It is doable. I have done it, but it's a faff. But you sort of, you bank them out, and then you write sort of one half, and then you change bank, and then you write the second half, something like that. But basically it's 3 writes instead of 1. I like that this library has copper AGA color. Setting AGA colors is a pain in the arse. This instruction allows you to do it easily in your copper list by doing all the extra work for you. Just apply the color register number and move the data into the RGB values, which is quite cool. So that does the same thing for AGA. It's just a single line and copper AGA color, and you can just sub that in instead of the copper move, and it'll do the same thing. Isn't that nice? I love it. But the problem is, because it takes like 3 writes instead of 1 to change the color, you can't do too many at the same time. You have to be careful, because what'll happen is you'll get color tearing and stuff like that, because it actually takes multiple copper cycles to do it. So on ECS you can change like six. Can you change 12 colors, 10 colors, maybe 8 colors on a line? Whereas on AGA, it'll take you multiple lines to do as many colors as to do a bunch of colors. So it takes a lot more. Yes. So to do fades, you need to do an extra conversion to split the 24. Oh. Yeah, it sounds pants all right. And that happens in a few places where you've got screen control registers and stuff like that, where the ECS values are still there and the AGA values are kind of like them plus 4 bits in another register. Fuck. So yeah, it is they have done an awesome job of making it backwards compatible, to be fair, but it comes at a price for the coders. But yes, that's it. Anyway, so that's what we're doing there, and it's as simple as that. So that's you wait for the particular Y position, and then you write in the value. So to answer Zuperdan's second question, all you need is the register for the for whatever color you want. So these are like we change that to 182. You can select the low bits, write all those. Yeah. Yes, indeed. Yeah, it's faffy. So I like that this guy has created a command to do all that faff. And if I ever do something in AGA, I will certainly use it. So what I've done is I've changed this to address 182, which I think is the first color register, and we'll see what that looks like. There's your effect, Zuperdan. And if we scroll that. Now, what you could do is you could leave the top black, obviously, instead of, you know, not having any copper effect. It is, isn't it? Oh, yes, yes. Oh, I had so many ideas for Ouija nights. Someday I will get time to get back to that. But yeah, so that's it in the first color register. You could also do it in the black color register, which is the second color register, I think. We'll try that, just for shits and giggles. 184. So difficult to see, but that's the shadow under the text. But yes. All you 8-bit Atari 8-bit fans will know the that almost every Atari 8-bit game has rainbow colors rotating through the text on the high scores tables. Always. Just like, that's my memory of them. And the reason for that is that the chips in the Atari 8-bits were designed by J. Miner and co. The same person who designed all the Amiga chips. So they actually run the same idea. So you can set up a display list instead of a copper list. But it does the same thing, just on a primitive 8-bit level. Same idea, you're just changing color registers at a certain Y position, and it just scrolls rainbow colors through this text. It's like... there you go. But yeah, so you can see there, it's subtle, but you can see that the shadow is changing colors with the copper. And that's a nice little lighting effect, actually. There you go. Anyways, yeah, so you can do that. You could even do it for multiple registers if you wanted. So you know, so you can change the background, and you can change another color. You can change multiple colors. You could, given enough DMA time, CPU time. But yeah, so that's it. Now, a couple of special cases to mention here. So yeah, what we're doing is we're adding 16, and then we're going back and doing the next line 16, next line 16. So it's always 16 apart as it moves up and down, based on the offset, which is what's moving the whole thing. Now the thing is that, you know, the way I said our screen actually starts way up here, and that's line 0, and the screen doesn't start drawing until line 44. When we do a 256 pixel PAL screen, that already starts at 44, so we're actually at about, what's it, 256, 44, 290 at the bottom. 300 at the bottom. Good night, John. Thanks for calling in. Good to see you. So what happens is, because the copper only deals with up to 256, it you have to do a special case. So whenever you get close to whenever you think the next cycle round, that your next command is going to be beyond 255 lines, you have to wait for that to pass. And then, yes, it is using hardware coordinates. Yeah, so it's fairly raw, if you like. But you have to do this wait thing is a special case. So what we're doing here is we're waiting for the copper command lets you put in a copper command directly, as you would if you're building it by hand. So some of us like it raw. Oh yes. So this command here basically is waiting for line 255. That's what the FF here, and the Y, it's the Y position of 255, and the X position nearly all the way across, and like just right at the far edge of the screen. And what that's doing, what that means is that the next command will be at line 0 because it wraps around. You see? So that's, oh sorry, we're doing that in the loop here. And if we've wrapped around, sorry, that's what we do. We wait until the wrap has passed, and then we reset. I was trying different values here to learn kind of how it works, because yeah, it's not something I've had to deal with before. And then we say we've already wrapped around, just to make sure that we know later on that it wraps around as well. So if the copper is finished up before that line, then we have to do it anyway, because we're dealing with the end of the screen now. So that's what that's doing there. So if we haven't wrapped at this point, we'll wrap anyway, but we don't do that twice. But that reason, do you remember there was one of the copper effects in the original library that wouldn't let me use a Y coordinate more than 210? That's why. Because it's using hardware coordinates, and it doesn't allow for the 255 thing. Remember, it was doing all sorts of weird shit. It was causing glitches and yeah, bitmaps, bitplanes going all over the place. That was because it wasn't allowing for this 256 wraparound. Like, fucker. There you go. They didn't take it into account, probably because they were only coding on NTSC screens with 200 pixels. They're like, that'll do. So anyways, that's basically, that takes care of that. And then at the end, we've got a copper weight of this. So do you remember I said you need to go doing it twice with no effect? Well, if you end up waiting for 255, you'll knock out anything like this one, which is waiting for line 50. Who knows? So yeah, let's find out, Nivrig. Let's find out. Let's see what happens. Well, there's your answer. That's oh, see, so you see that little step where it actually works? That's where it's above that threshold. Amiga Cami, welcome in, where we're experimenting with the copper, with some copper colored stripes, and we're learning. So yes, so you can only do that once, because you probably, if you don't intend to do anything after that point, then you don't need to do it a second time. But what's happening there is we do actually need it, and I'll talk about that now in a second. But let's just let's give Amiga Cami a shout out. She is doing some she runs Amiga game jams. She does some streaming with all sorts of things, including actual hardware, physical pinball machines, which I think is incredible. Floating mountains and chill. I don't know what that is, floating mountains, but cool. Give her a follow there. She's in Tasmania, so quite often streams when I'm at work, which is unfortunate. But there you go. Good morning to you. So what I'm doing at the bottom of the screen is just doing some tidying up. So what I'm doing here is I'm waiting for the end of the screen, and then I'm setting the background back to black. It's time for the Avatar game. Ah, okay. Oh, what happened? Not good. Oh, just everything. It was the malevolence of the inanimate. it just wasn't your day. Yeah. So anyway, do you remember earlier when I said that I found we needed to go 50 pixels beyond to get past the end and to sort of reset to stop it from wrapping around to the top, like we did there when we did this. So if we get rid of this copper weight, what happens is we set the palette to black straight away. So let's have a look at what that looks like. So you see what happens there. So as soon as the last copper bar is done, it's black. And it's a bit clunky. But anyways, yeah, so that's why that is there. The reason this one is here, so that's setting the background to black, and the reason for that is to stop it from wrapping around to the top of the screen and getting some garbage at the top, or well, not garbage, but just a band of the previous color. And this last one happens copper move. So this is the DMA control register, and this is turning off the DMA for the bitmaps. Sorry, the bit planes. Now, Superdan's first question was about the garbage that's at the bottom here, and you can see it there in the just before the copper gradient turns off, that the bit planes should finish after line 256 there, but they're going to about 258 or 259. And it's basically because I've messed with the copper, and the copper would normally switch off the DMA as soon as the last line is drawn, and therefore you don't get any glitches in the margins like that. But because I'm scuppering the copper's plans, it's going a bit beyond that. So what I have to do is I have to manually put back in the DMA off command at the right place. So this one is, so you just have to accept that these are the numbers that go in. So this is the address of the DMA control register, and 0120 is the value that I have found through Googling that needs to go in there. Oh no, sorry, not through Googling. It was in the other copper example I stole it from. So I know I would like this to tokenize better. So I know that these are the right values, but it's the wrong Y position. And the reason for that is it's waiting. It's in the wrong order. So it's waiting for the copper to set the palette to black, and then the next thing it does is this. You see? So if we move that line to here, that's going to switch off too early. Yeah, see, we're missing some of our bitmap. we're missing some of our bitmap. That's fine. So what we need to do is we have to add in a copper weight. 0, and it should be 44, because 44 is where it starts, and we've done 256 lines, which is where conveniently the right wrap, so it should be the very same value. So if we switch off the DMA at line 44, which is beyond the 256, 120 will kill sprite DMA as well, will it? That's probably fine. Good to know though if you have sprites that are operating that low. Or well, that's, they should switch them on for every frame, shouldn't it? Anyways, it should switch them on at the top of the frame. So yeah, so it shouldn't make a difference. But yeah, so 44 should switch it off at the right place. So we'll see if this has, there we go. Our garbage is gone. And our gradient still works. Oh! It's very satisfying. So just to make sure we have it at the right place, 43 should cut off the bottom line, yeah. So that's that. Sprite DMA won't switch back on. Oh. I knew that. I knew that, didn't I? Because you do that to make a sprite go invisible, to stop drawing the sprite. Sorry, that's right. Okay, well, yes, fair enough. The DMA con registers are documented in the Amiga Dev things, in the hardware manual. 100-bit planes only. Okay, let's have a look at the hardware reference manual. So, register summary. DMA con. So. So fine. Thank you, Nivrik. That's the one. That is a great resource. It's the Amiga ROM kernel manuals and the hardware reference manuals, all the development manuals, but properly converted to HTML, properly indexed. It's all really good. It's very, very nicely done by Elauer, however you pronounce that, and much kudos to him or her. So anyway, so you can see there, so see the way even in this it gives you the address just as yeah, I know, me too, because it has, from that, especially the hardware manual, all the Zorro stuff, all the kind of the auto config stuff, all that stuff that you need for hardware development, as well as this kind of end of things, hardware control registers. It's like, it's all there. And yes, you can download the PDFs of the books. You can have the books there, and there is something nice about looking through a book when you know where you're looking and what you're looking for. But yeah, when you actually just need to look something up quickly, and you kind of, it's really good to navigate those, the Amiga Dev docs. It is good. So you can see there the DMA con is 096, and that's the value we were using. So speaking of which, I'm going to run my own local copy. So you can see here the blitter. Oh yeah, there's some special things but yeah. So copper bitplane DMA enable. There's what you want, and copper DMA enable. You probably don't want to turn that off when you're using the copper. Probably bad news. It's like locking itself out. Sprite DMA enable, yeah. Okay. So there you go. Now, what I should point out as well is I think there is somewhere. There is somewhere that has these constants pre-made, so you can use the instead of 096 there, you'd use hash something like that. But I don't have that. If it doesn't exist, I'm going to make it, because that does exist as a list, and it just needs to be translated into the Blitz format, and that will be a script will do that. And even if it takes longer to do the script than to manually type in the hash symbols, that's the proper way to do it. Oh no, that's definitely not what we wanted. 096 $096. It was 096, wasn't it? Yeah. Still working. Yes, it is still working. So what I want to do now is I want to push it and see how far I can actually go with the bottom of the gradient before it affects the top, because I think I just picked 50 because it worked. And like if we add on 5 pixels there, now we've got extra pixels at the bottom. Although the copper isn't. Windigo, welcome in. How are you? The actual extra pixels are not. The copper, is the copper DMA actually being turned off there? Is that why we're getting these chunky jumps there? Now, la, 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 la. Good stuff. $100. Yeah. All well. Yeah, still got a slightly sore throat from last week. But no, I think. Oh, I wonder, is there only so far down that the copper can actually change the stripes? But no, surely it should be more than that, because you do overscan the screen further than that. So what is going on? I see there now. Our last stripe is overlapping there. 58. And that's the same. So once it goes beyond a certain point, it gets brought into the next screen. 65. 60. Oh, hold on a second. 58. That's what I wanted to do. Whoop. 56. Oh, 56. $56 is our limit. 44 plus 56. So there's an extra 100 lines is what we're allowed. But why? So we're switching off the DMA there. Let's switch that off at 54, let's say. Let's see if that helps. I know it'll be glitchy. No, the copper still is triggering at the same point. Thoughts, Nivrig? Oh, I know. Yeah, no, I solved it. There we go. Oh. Yes. Then I have to deal with switching the DMA on there. Ah. Wait. I don't get it. Why now is... I'm overwriting this copper weight, haven't I? So the DNA switches on when there's a copper stripe is beyond that, so we can never... That can't go. Are we getting glitches even then? We're not. Okay. That's just probably a coincidence. Or just an alignment thing, a look thing. Let's see. Yeah, it's just... Right, let's quit while we're ahead here. That'll do. Close enough. Anyway, yeah, there we go. Some copper learning experience. Okay, so now we have that working. We have to try and port that into our game. That's where it gets fun. So before I do that, I'm going to go and try and get a real drink. Well, first off, maximum weight line on PAL 311. Okay. But Yeah, that makes sense. But my query is why the DMA is getting reactivated. But it's because I'm overwriting this. Yeah, so I have to incorporate that into the main loop, I think, and just recalculate it on the fly then if I need to. Yeah, no, I can't be arsed with that. Actually, oh, you know what? Fuck it. I can be arsed. Go 56. Let's see if we put this in here, what happens. Well. Sad face. Turn off DMA straight away. It is glitch, but it's turning off the DMA, but also, yeah, that way it will do nothing with the VPC. Yeah. Yeah. Well, that's it. Yeah. So I was expecting to glitch when it's. Yeah. No, I don't know. It's working close enough. So I'm going to go and get a drink, and we're going to try and compile my game with the new. You turn DMA off 44 plus 256. Well, that's what I'm doing here. But when I'm in there, the only so this is what we had. But if I do 44 plus 256 there, it's the same thing, because I'm not worried about it when it's before that, because most of the time we'll be beyond that, because the Y position is already there. We're already beyond 256 at this, if we add this command. Doesn't that make sense? So we're already, oh no, we're all, almost. you could be, yes, yeah. Okay, well, we fixed the glitch. Just also shot myself with this. Y greater than 255. Yeah, absolutely. I'm just kicking that glitch around the place. So what's going on? Copper weight, copper move, copper weight, copper move. So, because we've already had a copper weight to that. But it shouldn't make a difference. It's just turning off the DMA twice. Yeah, well, okay, it's glitchy, but oh, no, we do need that for when it is within that range. So DMA. Okay, so we fixed the glitch, and now the copper bars are being ignored. In this case, because between 255 and 255 plus 56, we've lost like 50 pixels worth of copper. It's probably not 50 pixels worth. Yeah, no, what we're doing is we're adding that, but that's skipping a stripe, isn't it? Because this could be 256, and then I'm waiting till 44, and then going around the loop again and adding the next one after that 44. So I've made the stripe 44 wide minimum. Yeah, no, that doesn't work. Let's just leave it as it is. It's pretty. Nope. Ah, shit, what's happened now? That was 50. Yeah, that'll do. Yeah, I mean, I could. That's not the point, Snivery. That's not the point. You know that's not the point. I'll not have this thing beat me. Okay. True. let's just multiplex a sprite along the bottom of the screen to cover up the garbage. Such lies indeed. Such lies. I already did to try and fix it, and it didn't work. Oh, it wasn't enough. That's why the glitches are only 4 pixels below that line. That's why the glitches were never exactly against it. 270. Shh. Yeah. Let's go with that. That's totally worth an extra couple hundred bytes. Done. I'm only going to get a drink. Okay, now here's the thing. Definitely needed a drink. Don't judge me. I can feel all your judgmental eyes on me. This is Malibu and summer fruits juice. That makes me feel like 17 again. Oh, my brother got me a bottle of Malibu for Christmas like last year, I think, as a kind of a joke. Anyway, there you go. Right. That's looking beautiful. Looking beautiful. Let's right, let's port this into something. Or let's have a little bit more fun. Oh, slightly glitchy, is it? Yeah, something. It's skipping too far. Anyways, that's fine. Minor details. Happy out. Now, let's see where my... Oh, so let's close all this stuff up. Close, 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 close. I don't have my fancy gadgets in the corners of these windows, actually. You know, my with this style. Because it's not a public screen. Nope. Maybe. Clone. It is a public screen. Oh, I don't know. I don't know why that is. Okay, now let's go. What are we doing? We also don't need that. That. Jesus. I opened an awful lot of these. Wow. Jesus. I thought it was opening each one in the same tab. But I guess not. Would have been quicker just quitting and starting again. There we go. Okay. So open new and project SkyBlocks. scroll gradient. Okay. What was the other thing we were going to do? I was going to do. Oh yeah, I can't remember actually. Let's. Oh yeah. So the syntax and optimize commands changed in a recent version of AmiBlitz, and they just need to retokenize because they're compiler directives and not really commands as such. Someone decided, Juanitos decided that they should be capitals, and that's fair enough because other ones like def type and run errors on and stuff, they're all capitals, so it makes it consistent. But it means that when you load in, carriage at end of line, yeah. Starting at line 0. It means, yeah, it just means that when you load in text from one to the other, it'll give you it's like, you know, what are you talking about here, rather than retokenizing it. So yeah, you see def types and Blitz as well. Blitz and Amiga are compiler directives, so that's why that is anyway. So can't open the palette. Okay, so we need to set it up. To create release executable. Oh, that's a new item. That's create minimized is usually there. Okay, set CLI arguments. Okay, so create executable. This is where we choose where it goes. SkyBlocks. Okay. Oh, Zuperdan, did you have this issue? Were you talking there? This came up not so long ago, I don't think, or I think it's where the folder or the directory that the code is in is the same name as the executable. Is that it? No, that's different. Oh. Let's see what's happening. Let's call out good old Snoop DOS. It's not picking up the directory. That's a bit annoying. Did you create an executable first to set? Yeah, I did, yeah. That's what I thought the problem was. So create an executable. Oh. It's in the wrong directory. Let's see. No. I think it's still getting confused by the two subdirectories. Let's see. Create executable. See, it's gone back out to the previous directory. So I bet you if I put SkyBlocks in the path that will load. Watch this. Game. Now watch, it'll fail on the BG3 palette. Yeah, see? So it's it's using the parent directory, and I think that's because it's doing there's some they are I think that is a bug that's come in because of using the AmiBlitz 3 instead of some other code to do it, because that to me, yeah, but I don't want it to. When I choose to create the executable, I wanted to create it in there. See, and it did. SkyBlocks exe is there. It's created the executable, and then when I go to create it, okay, now it's after doing it. Now it can't open the IFF, and if I go back to it, create executable, it's back out to this directory. I think it's because it's trying to strip away the executable file name, and there's an algorithm for doing that, and there's a routine in DOS library that does that for you, and I think that works fine. But there's also one of the includes has a Blitz version of it. There's CAB3. So yeah, so what I have done is I've created a folder called a directory called SkyBlocks that has source code, and inside that there's a directory called SkyBlocks, which would be the, let's say, the release version. You see, so that has all the files and the executable in it. Yeah, and so when I compile and run, it's becoming the parent folder because it's stripping away SkyBlocks. It sees SkyBlocks, and it's stripping it away. That's a bit annoying. Let's see if I can fix it by renaming the folders. And that would point to... let's call that SkyBlocks release. SkyBlocks rel. Don't really want that there. So, well, where did my shortcut didn't work? SkyBlocks rel. Now, compile, create executable, SkyBlocks release, and let's create this. This is actually very annoying. It's gone back, so it's not that. Yeah, that's how I do all my projects. Is I have the directory with the code in it, and then the subdirectory I compile into, and that's my. And then all I have to do is that subdirectory goes into an LHA file, and that's it done. So this is a definite change in behavior. Watch. Let's see if this breaks stuff now. Whoa, that's a funny screen. Oh, this is running in a... So this is the 3.8. This is the previously working version. Oh, it's picking up. I changed the workbench screen settings, and even though they didn't take, it still saved the setting. What is it? 800 by 600. Yeah. Now. Or is it 1280 by 1024? Okay. So now, if we go back to SkyBlocks here, this is their existing code in the old version, and if we create executable, see... if we go SkyBlock, we can call it SkyBlocks the executable there. Oh, for feck's sake. Save that and create executable SkyBlocks. Runs. And we go back here and create executable, still in the subfolder. So that's a big one. That's annoying. Very annoying. I'm tempted to stay here now that because this is working. Because it's just a bit of a faff to rearrange directories just to suit the whatever slight bug or something is going on there. Yeah, I'm just gonna stay here. Right. Anyways. Not quite ready for me anyway, but it is probably, like you say, maybe a lot of people compile them into the same directories, but that's I would like, I always have a subfolder as like a staging folder, so all I need to do is archive that directory and then I can stick it on Aminet or wherever. I don't have to worry about putting, you know, all the kind of like the templates and the source code and the, you know, like pulling all that out of it. Ooh, it's weird, that drink. Anyways, right, here we are. Let's let's do our thing. Load palette 1. So palette 1 is giving us our gradient. So -1. So we're not going to do that. So we have to figure out how many copper instructions we need. But I think 50 is kind of a safe one. So after this, we create display. And we're using display RGB to make our gradient. So this is our game as it stands. Oh, not enough copper space. Oh yeah, yeah, sorry. Let's put it back just the way it was. And we'll run it. Just see how it is. Oh, I changed my emulation controls, Windows mouse. We've got 2 mice. So now we're back to 5. Already started terribly, so let's just kill that. Let's get up to a point where it starts scrolling. So this is brute forcing it in a way that shouldn't really be done. So we've started filling up all the copper instructions for every line with the color commands, and so now it's starting to scroll. Okay, grand. That's what we have. We're going to change that. So the -1 is it's a way of dealing with the internal Blitz commands. So there's our palette offset. We can probably just... Oops. Keycaps coming off my keyboard because this is a shite keyboard. Yeah, I think we're just going to end up rewriting this entirely. So let's bring in our test code. Copper test. Well, let's make sure it works in this version of AmiBlitz. Of course it does. Yeah. Beautiful, beautiful. An interesting thing that I actually noticed in some demos using is they use display bitmap and display palette before the display is created, which is interesting. So you're allocating those pointers before the display is started, and that stops, you know, sometimes you get a single frame glitch. Usually I get around that by not applying the palette until the bit planes are already in place, so because the palette is normally just black, so the glitches are there, you just don't see them. But that's interesting. Display bitmap and display palette before create display. So let's bring in our create copper. So we've got to create copper now. This is using an array. Colors. Is it? So. I wonder if this is particularly. Just look for the palette color. Is this particularly CPU intensive to do it this way? I feel like it is. What I might do is I might put this on 8500 speed afterwards to see. It shouldn't be a problem because it's literally doing nothing other than scrolling. But it's just inefficient, I would say. What is it called? Examine palette or what's the phrase? Palette info. Palette info. Let's go up here. I think we already put that in, didn't we? We did. Yes. So create copper. And yeah, see here's I was abusing this trying to get it to work. It never really worked properly. It was not right. So mismatched types. Oh. CY copper Y. Copper Y, yeah. CPY. CPY. Should be it, isn't it? Nope. That one there. So sweet. Yeah, because we're using a Y somewhere else. Offset. What do we call it? PAL offset, didn't we? We called that PAL offset. We actually do have that already in our code. Already installed? Yeah, we've some things to work out, but we never actually recalculate things. So when we're up here, display RGB should not be there. PAL offset. Okay, so this whole lot can go. Well, I know there's a function for doing that automatically. It's fine. Go so create copper is a PAL offset +1. And where's our PAL offset starting? Reset game. PAL offset. Start that at 44. Doesn't necessarily have to be, but lovely mixture of musics there. That's moving exactly right now. The only problem is we have black at the top. But it's moving exactly as I wanted it to already. So we've got glitches at the bottom and we've got black at the top. So let's... Ooh. Okay. So let's just have a look at how we're doing our... Load palette 1. Oh no, it's set into grey. So that's leaving... What's the first color? Shouldn't be grey. Why is it grey? Should be like the darkest of blues. Anyways, that also shouldn't be starting so low down, because if we want to scroll upwards, we should go to reset game and move that up a bit. So PAL offset could actually be 0. That's kind of what we wanted, isn't it? Yeah. Okay, I'm gonna switch off the debug because that's just very annoying. Okay. Just because we're doing some changes to it, let's change it to the 20th of September. Okay, now. Why isn't the first color dark blue? Is this something to do because I'm doing vertical screen scrolling or something like that? So let's see our copper test here. Where does it start? You know what? I haven't checked. Because it starts at 44. Let's go up higher and see what happens. Although no, it goes back. It goes all the way up to 1. So, and the first color starts as 0. Yeah, look. The actual copper colors don't extend into the overscan. They stop at line 0. Why is that? Why is that? Because the whole cop list started at 44. Is that it? I'd have to start it further up and then switch on the DMA manually. Then all my coordinates will be off. Oh. Yeah, no, that's well. Or copper reset. Javier, thanks for joining me. Good night. Good night. Thanks for being here and hope you have a good weekend. Yeah. I think, yeah, sorry, no, this is setting up our copper instructions to start at the same offset, so that's probably it. If we start that at 0, that should give us a much higher up looking copper. Shouldn't it? It's too dark, I can't see. It's still only kicking in at line 0. That didn't seem to make any difference whatsoever. Let's see if it makes a difference here. No. It does not. And then it runs out of stripes, and so it starts coming down. Let's just see what happens if we start the copper at 0. No, still. So that first line should be kicking at 0. And is it? So this is yeah, this is a little bit more complicated. So that setting that to black will at least get rid of the black or the grey stripe across the top. Oh, I didn't mean to press that. Get rid of that. Didn't crash. So stripes are appearing as they should, but I think what it is that I've only got like 44 pixels worth of stripes. Before we reach our lowest one and it turns black. Pitch isn't getting any higher there. So so do I actually stretch the stripes? Would that make more sense? Yeah, so what I'm thinking is yeah, what I'm thinking is we can sort of expand the stripes as well, so we get more pixels out of them. So if we've only got 44 pixels to play with, what we can do is we can create our stripes. And we can adjust that plus offset. So stripe size. So for now, 16 pixels. So what we want is, as we go down, that this stripe size gets bigger. So let's make this stripe size plus I. Let's just see what that looks like, because I think it'll exaggerate the effect, but it's already, yeah, you can see that the bottom stripes are larger. So the bottom should move more than the top. Well, the proportions are staying the same, yeah. But I think that works. What we need to do is Stripe size equals 10. So what we're going to do is, where are we? When we're falling, we're going to move less at the top, and then we're going to multiply that out. Oh, that doesn't work. Because we're already doing that every second pixel. So what we can palette offset, and what we'll do is at this start with palette offset and that's what we'll do. So we'll divide it by 2, and let's see what that looks like. Should look similar, movement wise. Yeah. Scrolls, it's probably going to be smoother. But we're running out of stripe again, yeah, so. So this should make it a much smaller movement. At the top. Did that work? Oof. Oh, we didn't reset it. Let's see what's happened. Ooh, ah. Maybe set that back to 16. Yeah, that looks. We'll deal with the switching off the DMA at the end there again at some point. Could, in theory, put a cheat mode on it. Ooh, slightly weird glitch there. Okay, we're not getting to the top of it anyway. Actually, that doesn't start there, so we can start down at size of 10 again, I think. With more pronounced changes in size. Yeah. Concentration face. Yeah, I think that looks all right actually. Yeah, I know the black will kick in at the very, very top, but sure. I think it's probably all right. Now, okay, so that's everything. Now copper weight. Oh, you know what? We're missing a stripe as well. And there is a limit to how fast you can go with music as well. So I think what's happening is I'm actually hitting against the hardware limit. So I was playing, I think those samples, I sampled them down to 16 kilohertz. And the highest is the hardware can go on a normal screen mode is like 28 kilohertz, around about that. And that's what's happened. I'd say it reaches 28 kilohertz, and that's as far as it goes. It just doesn't have enough DMA slots to do the sound any quicker. So that's all right. If we make that stripe smaller, how does it look? Okay. I think it looks quite good. Need a cheat mode, yeah. Yeah, I mean, I could easily... Stripes and the steps, and I think getting bigger as they go down, I think is actually a nice effect and buys me the extra pixels I need. Yeah, I think it actually looks alright. What I'm going to do is I'm just going to disable the speed up. Falling, finished move. There's our speed. Yeah, yeah. Ultimately, I'm doing this for me. that's all it is. So now the speed should stay the same all the way. Yeah, and then I'll fix the DMA at the bottom of the screen and just bring that up by a few lines because the actual bitmap stopped like a good 20 pixels above that. I haven't been paying attention, it's still going slowly, so I actually, you know what, there's going to be a test to see how far it actually goes before it crashes. I got that one perfect. Oh, getting eager now, too eager. Mix of music is atrocious. There we go. Oh dear. What was Y there? Oh fuck it, that's happened before, hasn't it? Okay, we'll call that. Yeah, I think this. Yeah, that's a kind of a crash, I suppose. Got locked out of it. Whoa. Whoopsies. Yellow Guru. Yeah. So yeah, I genuinely can't imagine anyone getting that far. But yeah, it's possible. Yeah, I wasn't paying attention. What level was that? Oh, more glitchy. $32, yeah. What I find odd is every so often it just decides not to scroll up like that one, and it's to do with, I think the blocks are 10 pixels high, but it scrolls 9 pixels or something like that, or 11 pixels. I'll have to check it out. But yeah, it's something to do with that. 29, 30, 31, 33, 30. Oh, music stopped. I think that that Bob just fell into the audio DMA. I was just set the speed too slow. Okay, so coordinates outside the bitmap. I need to do that with the debug mode on so I can see what the X, the Y is. Oh, but then it's going to go out of screen. Well, let's... I can't remember. Let's try it. Debug. Why didn't that work? Oh, it did. It just didn't show up until I pressed start. And why? Yeah, so it scrolls 10 pixels at a go. And then 6. One, 2, 6, 116, 106, 96. 86, 76, 66, 56, 46, 36, 26, 16, 6. It's when it tries to draw the new one, it's up too high. So yeah, it'll be... So if I had let those ones go across the way, they would have also ended up too high. Do I really need to put an end case on that? Or I think, you know, you get that far, you've crashed the computer, congratulations. Finished mood. Finished move. So I think, yeah, I think realistically no one's going to get that high. Famous last words. So let's see cam Y. Where's cam Y? Finished move. Cam Y. Oh no. Falling? Where is it? Where's the scroll? Up. Scroll. Yes, of course. But that's the finished move. Okay. Cam Y. So the cam Y will stop scrolling, so that's fine. It just keeps on piling up then. Good night, Nivrig. Thanks for being here. Thanks for the chats. And sure, we'll talk to you again soon. Good night. Cheers. So, it's not going to scroll past the end of the bitmap, but what's going to happen then is the Y offset is going to cheers. Yeah, Y position not -9. So every tile that falls, the Y position changes by 9, but the camera changes by 10. So maybe the camera should change by 9. As well. That would make sense. And it means it's going to scroll every frame then. We're not going to skip one. Yeah, this is every frame now. Cool. Okay, let's fix the DMA thing. Oh, no. Create copper. Copper weight 0.55. That only needs to be, well, let's do 45. And we'll keep the black there at the very bottom of the screen. 40. Have we lost our ability to scroll down that far now? So that's cutting off at the same point as the last stripe. I think that's probably alright. Although maybe we should stop the 42. Maybe we should stop the bitmap at the same point as the copper. So that's the difference in pixels. 40. So 44 gave us glitches. One line of glitches, did it? Okay, we're going a bit further now. Yeah. I think it's all right. I think that's all right. Yeah, so our stripe size gets bigger by twice the I value. I'm just thinking this, should we... It still means the same colors would be the same size. Yeah, fine for now. Fine for now. It works for now. Yeah. Okay, so yeah, so the DMA switch it off at 44. I thought that glitched at 44. Let's see. No, it seems to be okay. Oh, we never reset our stripes. We need to reset the stripes when we reset the game. Because as soon as it starts scrolling again, it's going to... yeah, jump. Yeah. So... go sub create copper. You know what? We'll take the... we'll take these and we put them before the reset game. And we put create copper in the reset. I think. So when we go to reset game, we'll do create copper in there. What are we calling? Create copper. Let's see if this all happens in the right order. Sorry, that sounds appalling. It's oh, game music's over for laughing the mod. Okay, so let's okay. So all the copper stays put when we press fire, reset back to where it was. Cool. Apart from a little glitch in the corner there, I'm fine with that. Oh, that'll probably do. Okay, so we're kind of at the position where it's basically just about the high scores table now. I'm happy with the copper grading, I'm happy with this. Oh, just doing that every once in a while, isn't it? Oh, dear. So what's limiting our falling? Fy speed. So, where is our Y position of the shape? How are we setting the position of our shapes? Angle. We're 50, 59. And 1. $50.59. So draw block. Okay, so Y size. So draw block. Okay, so but we're looking at points 199. Oh, excuse me. Block SX and block SY. So there they would reset game. $50. Block SX 50. Draw, so get a shape. X, come on, width and height. 60. So it's 60 high, and we're yeah. So the block is 50 pixels plus 9 pixels for the front edge, and so that's 60 pixels in total tall. And the handle's at 59, which is the 59th pixel, which because it's 0 to 59. So the handle is at the very bottom corner. So how is it falling out of the screen? So basically it's a Predator Gaming. Welcome in. How are you? How are you? Hope you're well. What do we got? Hey, old school Resident Evil. Very nice. Very nice. And Phase 101. Hello. Hello, hello, hello. Good evening, sir. Oh yeah. Give you a shout out as well. Cool. We spent a lot of the stream faffing with the copper and some new copper, well, not new, but like new to me copper commands. You know, as a different way of implementing copper stripes, and that's because I wanted a scrolling copper background. So ACA 500 is a great bit of hardware. That's fantastic. But yeah, so that's where we are. I'm just trying to fine tune things now. I've got a weird bug where every once in a while it will try to draw outside the bitmap, and I can't figure out why. So falling wise, so it will draw. Let me see. It draws. Okay. Cool. So falling X, falling Y. Oh, hold on a second. It's the X and Y, not the FX and FY that's breaking. Yeah, no bother. So I'm gonna have to try and catch this now. So forgive the music is going to be a bit gank, but this is my game with the copper stripes. So far, it's just a very simple game, but I'm trying to get it to. I'm actually trying to get it to break. I cannot get it to break when I want to. It's a game that I saw when I was on the ferry going back to Ireland from Scotland back during the summer, and it was in, you know, they have a kids entertainment area, and they had this touchscreen game thing for young kids, and they had this game on it, and I just thought, oh, that's actually really cool. And I had my laptop with me, and I started coding it then. So, but it's like also relatively simple. But I'm scrolling the background stripes with the you know, to give a slight parallax kind of effect. That was the intention, but I can't get it to bug out for me. Stacker and okay, cool. I'd never seen it before. It's a simple concept, but it has never come across it. There you go. Now, this is different. This is the new lock. I've been looking in the wrong place. Yeah, I've been looking in the wrong place. This is right after it draws the debug info. So it's after the turn had finished. I'm going to switch on debug mode, so we get a load of garbage on the screen. But I have to try and. So it's when it draws the next shape, when it's coming in from the side. But all I can think of is. See, none of them are anywhere near. I don't get how this is ended up outside the bitmap. That's trippy. I don't even know what direction it's out of the bitmap because it doesn't draw it, obviously. But it is definitely when it's drawing the next shape to come in. So is it coming from the top? Going nowhere near it. What am I missing? What am I missing? What if we make a really skinny one? X is going up to nearly 200. So it's, and it's only 50 wide, so it'll still only be 250. What if happens if we make it really skinny in the Y direction? But it can't have gone down that far either. It has to be in the X direction. Oh. So finished move. We do our next block. We get our next block. And then we choose one direction and then move up 9, which is fine. And then we go ISO to ortho, I presume. ISO X plus 160. So that puts it in the middle of the screen. Plus ISO Y. Let me have another look at this. Let's see if I can get it to go. ISO X. ISO Y. So what if we do it really far over this way? Oh, this is wrecking my head. Yeah, I've my brain has turned to mush at this stage. Right, I think I'm gonna have to leave it there because I can't figure out what's going on with this. So, we need to make some notes. Scroll gradient is done. Done. Investigate weird based on palette. Done. Fixed in this one. Fixed in this one. Better sounds. Nah. High score table we need to do in competition mode. Yeah. But the big thing is when starting the next block, next tile. Is it I think it's going to be something to do with that. We will see. We will leave it there anyway. I was also trying out the new version of Ami Blitz earlier on, and it's all looking very good and has some pretty cool extra stuff, but I have a couple of small bugs, and one is kind of like basically a deal breaker for me because it wouldn't let me compile into a different directory than the source for some reason. So, and it works, so I went back to version 3.8 and it works fine there. So there we go. Anyways, I'll report them to Juanitos, who is very good at fixing these bugs, to be fair. And right, that will do. Let's see, who are we going raid? Is there anyone on to raid? Who is on? Kiffer Amigos Retro, Charlie Farr. Thanks, George. Do you want to drop into Charlie Farr, or we give Kiffer Geo a raid? No, all good, all good. See you, James. We're always raiding Kiffer, so let's go and give Charlie Farr a raid. But no, all good. Thank you all for being here, and yeah. Talk to you next week, probably, hopefully, maybe. Cool. Cheers, and maybe we'll fix this at some point. All right, listen. Take care. Good night.
Raiders, welcome in. How you doing? Welcome in, Raiders. How's it going? What you play? Thank you so much for Raid. And what were you playing today? Right, I'm gonna try. I'm gonna try hard. Hey, dude, Faze, welcome. This is a legit raid. Yeah, welcome in, Deadlist. What were you playing today? Well, thank you so much for the raid. What were you up to? Happy Friday, everyone. As having a week. Oh, I'm struggling with controls on this. I really am. I found this bit counterintuitive. Doing some Blitz Basic coding on the Amiga, nice. So what are you trying to code? What are you coding a game? Are you coding an app? Are you? Oh, have I missed that? Oh, flipping it. Controls on this. Making a stacker type game. Oh right, it's junky spot. Would you like these, like where it goes left and right? And you try and stop it on the thing. Oh, once I know it's here though, I have to get it. I'm probably going to die now. I'm going to have to use it, aren't I? I've never once made this yet. Oh my god, we've done it. It's happening. It's not happening. Actually, we're probably fine now. It's the first time we've not died on that bit. Getting good. Exactly, a pseudo 3D one. Oh, right, cool. Yeah, what's new Wednesday? It's, you know, the door's open to any dev that writes a game. I'll show it on what's new Wednesday if you want me to. I don't review anything. But yeah, hope you had a good stream. We're doing some long play auditions, we call them here. So I'm trialing games for a potential game to long play. I'm looking for something for games that are a little bit longer, and then on Fridays we will try and play them. Some games are going better than others. Yeah, no problem, Deadless. Right, we're back in the room. What time is it now? So it's only noon. I don't know what we're doing. I didn't mean to do that. I need all the health. Right, should we go this way? So we're playing a game called Full Quiet, which is on the NES. And it's like some kind of survival horror game. So the puzzle game's going to murder me, because you see, I didn't realise I was losing health every time I was failing at it. Oh, we can't do it there. Why is it not going down? So we need to do that. That opens up the well, I guess. Should we go this way? Oh, we've got it. We're doing it. So I think they're not random drops, these, are they? They seem to be the same drops every time. full clip. Are we going this way? We are going this way. Not random, no. Right, in we go. Oh god. I'm gonna panic like hell now. You ready? So we've got a train. Heck. Flipping heck, we did it. Right. I really want to save it, but there's you can't just save anywhere, can you?